In this video, we'll be looking at how to make a Nintendo Frankenstick. Hi, I'm Andrew Armstrong and welcome to the Back Office Show. Don't worry, I'm not going to be filming a food video eating my snack here. I wanted to show you a video about this joystick. So I pinched this out of Neil Retro Man Cave's Man Cave. I don't know who makes this. Is it Quick Joy, Quick Shot? One of the others. Answer down below. And I really like this aesthetic because we used to have them on the old Commodore 64 and things like that. And I thought this would be quite nice to use on a modern day PC. And you know, I buy these USB joypads. I use them for loads of things. In fact, sometimes I even play on them. But I sometimes use the innards for projects, and then at other times I use the outards for projects. So it's pretty cool. But it does mean every now and then I do end up with a surplus of an innard or an outard. And I currently have an innard. And I was like, ooh, let's put these things together. So that's what I'm going to be doing today. But first things first, one bite out of this. Now, if you've not seen these are a British delicacy called a crumpet. And what you do is you toast them and you fill each of those cells full of butter. So it ends up with this crisp, buttery goodness. Look at that. Damn. And of course, a bit of coffee to wash it down. Right. Let's get on with it. Let's see how much room we've got to play with here. The old screwdriver is getting a bit magnetic. There are a few options to demagnetize your screwdriver. Apparently some of them to do with dropping them. But if you're lucky, there's a tool that you can buy that's kind of a bit like a circular magnet, and you can use it to not just magnetize, well, demagnetize, but actually also magnetize. So it's pretty awesome when it... Oh my god, Neil, what the hell is inside this? Got filth all over it. And there might be the possibility of replacing these with genuine Sanma parts. Oh no! Don't! I might have flicked some of the dust onto my bloody crumpets. That's no good, is it? Right. So the first thing is to see how much room we've got to play with. So you've effectively got the whole of this bottom. So we'll just unwrap this, see what we've got to play with. You can hear the washing machine in the other room going mental. Of course, we're not going to be using all of the buttons on here too, which is kind of a shame. But at some point in the future, we might be able to add those. And also what we can do, instead of having a single fire button, as was common, we'll wire these up to be, two separate fire buttons. Not sure which buttons we will use though on the old USB for that. I'll probably go for the ones which are assigned normally to these two here, K4, K5, K2, which is A and B. They seem to be pretty common. Save us having to remap everything in software every time. That's interesting, isn't it? I didn't know that came out. Oh wow, so these were really quite well made there. And look, there's even a kind of a plastic bearing to push on those, so they're eminently serviceable. I bought one of those Commodore CTV things, and I bet if I open it up it's not nearly as well made as this thing, even though it kind of looks the same. I'm pretty sure it's not as well made. So is there a way to fit this easily? Doesn't look like it, but let's see if we can kind of just maybe fit it diagonally by chopping off a corner. And I'm going to try with the scissors. Pretty unlikely, to be honest with you, but yeah, there we go. I think we might get away with it. That would be amazing if we can. Because we can just basically leave it more or less intact, so we can add buttons and other features later on. So be careful here, there's actually a piece of tracking. I'll zoom in for you. You can see that's the circuit board that's making the circuit ground to a lot of the circuits on this part. You can see here I've cut it, but it's still connected, so be careful this end. You've got less to play with. But if you actually cut it, you can always just solder across. We're going to be doing soldering today. There's no way you can do this project without having to get out a soldering iron anyway, so don't worry if you go a bit too far and you nip into that. Oh, I literally also just flicked that piece of plastic again over my food. Food in a kind of lab setting is not good, and I'm starting to realise why now. This is how you get poisoned. Now the more you can trim off, the better really, because it'll fit lower and lower in that shell, because the shell is kind of chamfered. Yeah, I think that's going to fit anyway, to be honest with you. So have a look now. You can see the edge of the board is nicely rounded. So I've done that that thing I said I would do, where I've actually gone in and I've actually clipped some of the tracking there on those ground planes. So we'll have to solder those in, but that's not a problem, because I think you can do a really good job of this. I'm just going to desolder the K6 and the K5 connections. And it's good practice in a way, because you might want to actually fit this in a different case altogether, and you might not have the luxury of the masses of room this case is offering. So I'm just going to desolder this one. Now if you remember in the past though, I've made these super tiny. If you really want to, you can almost go back just to this blob chip. You do need to make sure you don't damage this capacitor. In fact, we might just desolder that and flip it over. It's better on this side for us. But yeah, you can get this down to virtually just the smallest amount of PCB. I'm just going to turn up the old soldering iron. It's a little bit cold. Put it up to 380, give us a bit more thermal mass. And that works perfectly. I'm trying to think, I've basically managed to put this into one of those tiny little project cases that are about an inch and a half by an inch or so. So you can really get them down. You don't have to buy fancy schmancy USB modules. These whole SNES joypad things, I think they're only a couple of quid each. So they're really, really good value for this type of project. So I've removed those. We don't really need those right now. We're never going to use them again anyway. So now we're just going to lift that capacitor, because if we do that now, we'll be able to sit that down as far as this possibly could have gone. Now you've got lots of ways of doing that. Of course, if you've got solder braid, then that's good. If you don't have solder braid, you can try all sorts of little techniques. So sometimes one of the techniques is to heat one leg and then push it down with your soldering iron while it's still all warm. I can see me fumbling, but there, you see that? I've pushed them through, so the component has actually almost dropped out the other side. And then I'll just gently, remember, you don't want to damage this. This is quite a hard crystal to find. It's a, what does it look like? Is it a 6 meg? I say it's a crystal. I can't remember if it's a crystal or a cap. I'll have to check that. Getting warm. And the weird thing is, when this crystal or capacitor, I'll check it out now. When this component, should we say that? When this component fails, the whole thing kind of works in USB, doesn't work. So your USB, it affects the USB timing. So we're going to pop it into this between 1 and 3. Let's see what we've got here. So here's our little tester. And it's saying it's a 31 picofarad. There you go. A 31 picofarad capacitor. So if you need to, you can. And I think once I did manage to actually repair one of these with a piece from an old motherboard. So I did find a capacitor on a motherboard. So you have options. And what I'm going to do is I want it to be probably flat. So I'm not really going to bother soldering it through. I'll just solder it surface mount on its side. It's good enough, I should think. If it's good enough for you, it's good enough for me. I'll tell you what, this solder does not want to melt. It's definitely seen better days. It might have oxidized. I'll just add a bit of solder to these now that I may. And we'll just have a little look, because we need to make those ground links. So we know now that this one, I'm going to zoom in so you can really see it. You can see I've taken off that whole corner. So if you've got a bench like mine where you've got electronic kits in play, have a little look around and you'll find, if you do through-hole stuff, you'll find legs of things like that lying around, which are ever so useful for this kind of thing. So I'm just going to apply a blob of solder here. So that's ready. And really you want to solder it. In fact, looking here, we've actually cut off the line that's going here, so it's cut there and cut there. So we actually want to solder to this pad here, this one on the left of the K6. So that's a bit of a tricky one right now. So we might need a bit of longer wire. But I'll just show you the example. If you were going to solder just to there, what you would do is get something like an old screwdriver or a more appropriate tool if you have it, and you can just scrape it. See, just like that. Just do a little bit of scrape. In fact, I'm going to do the actual repair on this one in the same way. So I'm going to just scrape it like that. So as long as you don't bridge this left-hand side here, it's going to be absolutely fine on this as a repair. So I'm going to just solder that there to the edge. So that's now in place, and just let that cool. And once it's cooled down, you can sometimes just hold something on it, take that heat away. You can actually just shape that. It's like making a track. So you could use this technique for replacing tracks you've pulled up on an old Spectrum or something, which is easy to do. I'm just going to cut it there. So that's pretty much going to be the perfect piece of track. I have about 2,000 times the current carrying capacity of the original one. And I'm just tinning the areas that we want to solder this down onto. And you can just feed some solder in from the end. It's a bit like welding, really. It's no different from... Oh, no! Don't do that. Don't apply too much heat to one little piece of wire. There you go. You got to see the gotcha there. Don't give up. You know, all is not lost. I'm just going to take this and try to orientate it the best way I can. So I guess the answer to this is be quick. You don't need your soldering iron on too hot either. I remember I've turned mine up to sort of nearly, 395 degrees. I think you'll get away with sort of 180. Now just that last piece there, I'll just bend that in. Just see me bending it just in like so, right there. One dab of solder, and if you're unsure, if you've got a multimeter, just check the continuity on that ground plane or ground connection, and it's going to be good, I'm sure. And I'll show you how to do that, and then I'm going to go and just wire up the other ones. So there's our meter. Get your meter out, switch it to the one that looks like it's got the buzzer or the ohm symbol. And mine's on the, so if yours is on the ohm symbol, when you cross them it'll say 0, or it'll just say OL, overload, overthing, whatever. Or if it's on continuity, you get the beep. So I'm going to hold it here on this pad, and then I'm going to hold it to the left of this K6 junction, and you can see continuity. So we've got the power going through. And just as a double check, I'm going to touch it on the other side of the pad, because these things are zigzagged, and if you made a mistake you would cause continuity to that. And then unfortunately the X button would be permanently pressed down. And then so that's pretty much it. I'm just going to go do the same again over here and over here, because they've gone a bit, they're not, I think they're actually okay, but just a bit too close to the bone for me. We want it to be reliable. And then we'll see about putting it in the box. It's time to start soldering, and just to show you what I've done, I've glued the board down so that's firmly down, as far down as it can go. So you want it touching the ribbing here, so that's pretty cool. So it's pretty low down. I've put a blob of hot snot to act as a strain relief from the wires coming out of the PCB, because we can't get to the connectors on the other side, so if that breaks it's going to be a real pain. And I've also put a bit of a cable tie on the end here, because that will marry up with this hole, hopefully. In fact, let's just test that. And then provide you that strain relief, that when someone sort of yanks on that, it's not going to pull it out of the bottom of the PCB, and you can see the cable tie right there. And if you want to, you could put some heat shrink on that and do a better job, but I mean seriously, if it's you playing with it, I doubt you're going to be putting in that many hours, but if you are, a bit of heat shrink there would give you a little bit extra, but meh, I think it's alright. So next thing to do is to take your PCB. And it's kind of easy in a way, because all of the grounds are hooked up. So you only need one ground point. And I'll show you where the ground points are on these boards. They're actually the ones that you've already soldered. So actually, technically, we didn't really need to do all these shenanigans, you know, because we're not using these pads. But I'm glad we did it anyway. Because it gives you the option of choosing a ground point anywhere that's convenient. So, for example, if you're going to use... ground point, we're going to these are the up, down, left, right, so we're probably going to solder from here to here, so we want wires to come to a common ground ring. You can just take it from here. This pad here is a massive fat one. Plop that there, and there's your solder for your ground point. It's that easy. So you've got your solder there for your ground point. Now let's just add some blobs, because we're going to want to hook our different wires for the different signals. So we've got here our left blob, And I'd use the small, there's a little small hole. You see there's a small, like a test point next to the pad. Just use those. So up, right, and down. So there we go. And then on the other side, we're going to choose our buttons. And we were going to use, if I recall, I'm just trying to remember which ones are the best. I think the A and the B we decided were the best, which were the K2 and K4. So we're going to put one here. And you can see it's really sad in a way because we've got so many other inputs. You're losing out 1, 2, 3, 4. You've got 4 more buttons you can add if you really want to. And again, depending on your need, if you think it's better to have the start and select buttons hooked up, or one start and a fire button, that's up to you. I'm just going to go for the 2 buttons. Whatever else we need, we can remap in Windows. So let's work on this thing. So this is the bit that's the controller, and I'm going to make I don't know what you call it. It's the controller microswitches. So I'm going to make a mark here to show where the wire side is. So we want the wire to be that end, so we know how to orientate everything once we start soldering. And remember, the way the stick works, when you push up, that goes down, so everything's opposite. So when you push that way, it's up. So that means this microswitch is the up one, that'll be the down, and then if we go right, this is the right one, and this is the left one. So we've got to be careful when we flip it over. I'm just going to write here so I don't forget. Look, left, right, up, and down. So that's kind of a handy reference. We'll be using that just momentarily. So you can use whatever wire you've got, pre-terminated or otherwise. I'm going to use Kynar, and I'm going to try that trick again. Not sure it's a great one, but it seemed to work a bit last time, where we just kind of lashed it. There are wires basically designed for this. Certainly not, heat-proof Kynar insulation, which is almost impossible to melt, but it did melt a bit last time when we made that panel. So I'm just going to hook it up to the ones. I'm going to make all the ones common basically because that's kind of what they should be. But I think you could get away actually if you make the other side common. It's not really a problem. You're not using, these are sort of not microswitches where you're using a normally open and a normally closed. So you can see I've just slung that through there. Now I'm going to heat that hot. Now if you've got your soldering station, just put it up to maximum because you're not really using it as you should. So I've got mine at 480. At that temperature, be quick though. You don't want to dilly-dally, and you certainly don't want to leave your soldering iron at that temperature because it's going to start eroding the tip. But I just want maximum temperature. I don't want to mess around with this. I want it to sort of just get in there, melt the insulation, and get the thing mounted. So there, that's the first one done. So what you do, take your wire and then just wrap it round all of those terminal ones on those micro switches. So you got 2 wraps there, and I'm going to bring it back down underneath, give it a bit of slack there. 2 wraps, 1 wrap, 2 wraps, and then we're going to go down to the other down, and then we're going to do again the 2 wraps again here, 1 wrap, 2 wraps. So yeah, and we'll leave this trailing wire as long as you can for now. And then I'm just going to get the soldering iron. I'm going to just hit it hard on that joint. So have a look. Come in close. Have a look. I'll try to hold it up. Let's see what we can do with this. Let's get that a bit tighter, as you can see. And of course, remember, this still is a switch. You don't want to hang around and have lots of heat get into that switch junction because you could melt the internals, the plastic and all sorts. If you want it to be a little bit more compliant with your requirements, you could tin the microswitch cable first. And of course, if you've got terminals, you might be more inclined to use terminal connections. Just, yeah, feel free to use those. And you can see here, the insulation of the Kynar is yielding, and it will eventually go. It's a bit messy. It's not ideal. I don't really like doing it this way, but it does save ever so much time. Maybe if you solder them as you go along, though, you might not have them fall off like that annoyingly. Let's try again. I think someone did say last time if you kind of abrade or cut the insulation, it will do it a lot quicker. Let's try another technique. I'm going to hold the iron on the insulation. Oh, I could see that melted it quite nicely. And then that way we're not getting too much heat into the microswitch before the insulation starts to melt. Yeah, I mean that worked. I mean you can see that actually has soldered it, so you don't need much more than that. Again, what would you do? Would you use terminals? You can. There's probably just about enough room. It's funny, really. I don't think it's something I'm likely to be servicing in the future, and if I am servicing it in the future, I certainly will have a soldering iron to hand. Notice the camera's having trouble focusing. I'll just do this one on its side, get it done. We're there now anyway. Last one. You know what I'm up to. There you go. That's that one. So once they're all connected, you can test that obviously with your multimeter if you want to. I suspect we probably will just test these before we put it all back together. Put that aside and then just keep this wire, I don't know, you don't really need it massively long, but it's nice and thin, the Kynar, so I'm going to cut it off at a couple inches for now. The reason is it's just going to that connector there that we made, so that's that wire. In fact, let's do that, shall we? Show you the process. So the nice thing about Kynar, the bad thing about Kynar is it's really hard to strip, so I kind of have Kynar only stripper for that. It's a little bit fragile. I'm not going to solder it just yet because I want to do all the other wires. So what you want to do, if you've got Kynar, just sit there and basically strip an end like that. Nice and easy. Measure out what you need. So if this one is the down, for example, we know we've got to go, let's just check that's the right way. That'll actually be that way. That's probably the worst way. Didn't leave much length on that. I'll have to solder it that way. So yeah, that's the down. Just make sure you've got enough wire to go from there, which is the down, to there, and then just cut that, strip the other end, and then solder it in. So I'm just going to do that now. All the wires are pre-cut now, and I have stripped the ends, so we'll be able to fit this. Let's have a look. So just make sure, again, it's going in this way. Okay, so you want to make sure your wires are going to the right point. So I'm going to flip it that way. And this one is the right hand side. So nice and simple. Because we added all those blobs to the board earlier, all you've got to do is hook this onto your Microswitch. Again, I've pre-tinned these, maybe just off camera, I can't remember. And that means I just don't need any solder. There's already a little blob of solder on each of the legs. It's the same way as this. And then I'm just going to touch that down, like that. Watch where your little fingers are going, of course. And then you just do the same really for the rest. So that's the right hand side. And then here's your left. Bit of a stretch on the left one, but it's not too bad. That's the left, and I will have to put the ground in. You can see I've cut that ground wire that we did earlier because it was a bit too unwieldy where it was going. And then we need to add our up from here. Again, take your time if you're a perfectionist. It's up to you. There's no rush. Depends. It's interesting actually. There's sort of a couple of different types of electronics persons, or electronic tinkerers, I suppose we are. Those who spend a lot of time making their work, look really amazing and doing a great job, and that's absolutely fine. And then there's others like me who just put it together in a way that I know is absolutely fine functionally, will work well, be just as reliable. But I'm not really that bothered. I don't see it. I don't need to make it look pretty. I don't care about what it looks like under the hood. And there are a group of people who don't like that. But it's not your job, right? If I was being paid to do this, I'd take my time. I would make sure it's a good job for my boss. And at the same time, of course, my company's paying me to do that. You're being paid literally by the hour to do that. Whereas at home, you're not. Just do it however the hell you want to do it. If it's going to give you the same result, just don't waste your time. Value your time. A lot of people don't value their time on hobbies and projects, but yeah, value it. Still time that you're not spending with your family, or time you're not spending doing something else. So there you go. That's all connected. See how quick that was? Pre-tinning. Stripping and tinning. So that part, that's pretty much done. We can actually just put this piece in and forget about it. We don't need to use this common ground. We'll get a ground for the buttons from up here somewhere. So we're just going to have a look now, see how to get this nicely. So you want to make sure, if you can, that the wires are not in this center area, because that's really where the tip of the joystick, or the end's going to sort of float around in. So once you plop that in gently, just don't snag any wires, and see how best to route them. I'm just going to pull a few through. That's quite nice really. There's no wires snagged in there. I'm just going to stretch these out and push them in the right place. You want to make sure they don't hover around any of the holes, because you might put a screw through and rip one up. And Kynar's quite nice because it's a single strand wire. It's not like a flex that'll flop around. So once you kind of bend it in, it'll stay bent in. And I would just say leave it like that. I wouldn't worry about it. You know, look in there. You can see there's a little tiny rat's nest. Just leave it. It's not going to rattle around, and the cable doesn't have the mass that's going to shake itself damaged. So that's fine. Leave that like that. Now I'm just going to turn this way because we'll get a couple of wires out there in a moment. And what I've done with the actual leaf springs, I've already put a ground in. In fact, that was the old ground from that I just sort of chopped off because waste not, want not. So what I'm going to do is solder 3 wires to that, and I'm not going to make them too long, but not too short. So you're going to make them a couple of inches long each at least, so you can reach. And let's just do that. It's quite a quick process when you get the right cutters for Kynar. There's loads of people with sort of differing advice really on how to do it with different strippers, but there is I advise just get these are quite cheap, and then what I do is I'll just sort of tune them in by hand. They take a while to tune in by hand because they're actually quite a coarse tool, but what you do is you move this nut back and forth, and that blocks this handle. You can just get it kind of just how you need it for Kynar, and then once it's tuned for Kynar, only ever use it for Kynar. Because you know, if you eat a bit of wire or cable that's a bit too thick, you're going to put a dent in it, you're going to kink one of the teeth or something, and then when you go to strip that Kynar, it just won't work. So you've got to remember, this Kynar is real thin. I mean, I'm just going to have a look now. This is 30 AWG, so look up what 30 AWG is, but it's a fraction of a millimetre thick. So think of the insulation you're trying to get off is even thinner than that, significantly thinner than that. Okay, so I'm going to hook the PCB ends up first. So that's one of our buttons. Now I'm not really too bothered which way round our A and B button go on the actual Competition Pro, because I suspect whichever way it goes, it's not going to be perfect for any particular thing. It's going to be right for some games and not right for the others. So if you imagine a Commodore 64 or something, I don't think it'll use the button, so you could probably map both buttons to what you want on that one. You're not going to be able to play SNES or NES games with this anyway unless you map some keyboard controls, so it's not a good thing for that. Atari ST only uses really the one button. Amstrad CPC, I think you can have 2 buttons, but I don't think any games really use 2 buttons, so up to you. You might want to map the second button to some sort of menu function, or if it's got it, a turbo control. So that's the 3 wires now hooked to that. So this is the ground wire. So I'm going to hook the ground wire to the one where I've commoned the 2 up. And it doesn't matter which spring you decide to make your common spring. Whichever one just happens to be easier. I've gone for the bottom one because it's the more annoying one. So I thought always get the annoying one out of the way. And that is bloody annoying. That's 3 times I've had it and lost it. Stay down. And that's that. That's good. And then we're just going to go, I'm just imagining when this is shut, we'll give this one to this one. You want to make sure there's a little bit of play in the wires, and make sure you solder the wires the right way round, at least, that when you put the case on you don't snap some up. And that is that. So I'm going to show you this now on that one cools. So that's it, just looks straight like that. You can see they're so wispy, aren't they, these wires? But they're more than enough for carrying the signal the joystick's got. So just make sure now when you poke it through, these wires are not interfering in any of that mechanism and not getting under those leaves. So I'm going to kind of pull it down the side like that, but I'm making sure, let's just wiggle this in. I'm going to make sure now and turn this around so that those wires, you can see them sticking out the side, have a nice home to go into. So I'm just going to hold it half open. Just take the screwdriver, run it through. And I'm going to make sure they've gone down there, but they're not interfering with that last screw hole that's just on that side of the case. Let's push that through, and you can see there's our strain relief, and there's the wire there. I mean, if you want to, you probably could put a bit of glue in there too to stop that wire going in and out, if that's going to annoy you much. Will it annoy me? Yeah, maybe. So I'm just going to see if there's any other option. I try to stuff a bit of foam in there or something. Just looking at it. You know what? Screw it. It's good enough. I've got an escaped wire here. I'll just poke that one back through. I suspect you're never going to have to go in there again. So let's just get those screws on, and the last stage is just testing that. It's pretty easy really. I mean, this probably could have been a 30-second video. Take the lid off, screw this here, screw that there, but sometimes it's nice to get the whole thing to see what the gotchas were, because you know in some of my videos I'll go through right to the end and then the thing bloody won't work. And what happened the other day, actually, there's a video that for electronic kit, and I did that. I went through the whole thing. That's worrying. That one is actually, that screw. Oh, why is this screw doing it too? Got a couple of screws that seem to be a bit stiff. Don't remember them being that stiff coming out. Okay, maybe that's just the way they were. Hopefully they're not dashing my wires. Cool. So let's see if this will work now on a PC. Okay, quick one. It did work pretty well to start with. The Microswitches were a bit gummy, so that's something I might have a quick look at while I'm in here. But what I noticed was the buttons I've used are 2 and 3. So what I suggest, instead of using A and B, use X and A. X is button 1, so I'm going to make X probably one of the other switches here. Let's get that off here. So X and A is what you want. X might be good on the left button if you're in a normal right-handed way of holding it. X and A. Let's try that one. Ooh. Gently, gently. There we go. Right in there. It's quite easy to mod that. So X, well, we want this bottom one to be X, which is currently going to what I guess is B. Well, I need to check that. And I'll show you on the standard pad what they look like. In fact, that was A it was going to. You want it to be X and A, then that would be the left button and that would be the right button. So we're moving this one to where A is, which is that one. And we're swapping A to the X position. I just knew I'd have to get the cover off. I'm wondering though if it's possible. You've got the Microswitches here. Say these were a little bit gummy. So I'm just going to put a tiny bit of PCB cleaner on the ends. See if that'll go in there and just sort of flow in, loosen them up a bit. They did start to get better just through use, but that might just help rush them along. And I remember while I was there, I wanted to make that a little bit firmer on the strain relief, so I'm going to see if I can cut a piece of foam. So I'm just going to cut a piece of foam here and lodge that in there. It's part of there's a bit of a grommet here. See that piece of foam? It's just going to compress that down and hopefully get a nicer thing that will be less wobbly for me. Just put that on. Again, take the care. You want those caught wires. And that's a caught wire, so I've got one, I could feel it, so that's a good thing. So at least maybe if you've got a caught wire, if it's putting up a bit too much resistance, you've got one in the wrong place. That's it, nice. Okay, let's try again. Well, unfortunately, it hasn't improved my gameplay much. However, it is the original experience here, and I'm not really detecting too much lag or anything like that. It just works as you kind of expect, really. So yeah, mission successful. So now I can enjoy playing these with the same horrible joysticks that we used to back in the day. So there you go, Competition Pro USB. Thanks for watching.